I think I'm gonna go back and just do this proof. You guys already did it in your notes, but just to watch it so you get a reminder of how to do an algebra proof. How was your trip to DC, those of you that went? It was good? Tired? Good deal. All right, so let's start out. So like I said, we already did this one, but I just want to kind of review for those of you that may have forgotten over the weekend. Okay, so step one is always given. No one should ever get that wrong. Okay, and then what would you guys do next here? Distribute, right? So we'd go 2 times 5 is 10, minus 2 times 3a is 6a, minus 4 times a is minus 4a, and negative 4 times 7 is negative 28, and that equals 92, and that is distributive property. Okay. Then, it's interesting, we are doing the 2-4 notes, we're finishing that. And then there's also a cheat sheet that, like a formula sheet for 2-4 to 2-9. So if you wanna find that. Okay, now, what would you do next? Simplify, yes. So I always put my a's first, so I would combine that, and negative 6a minus 4a is negative 10a. And then 10 minus 28 is minus 18, and that equals 92. So again, what we did there is like combine like terms, and we call that simplify, okay? What would I do next? I would add the 18, so I'd get negative 10a equals 110. So that is addition property. And then the last step, I'd divide by a negative 10, and I'd get a equals a negative 11. And so that is division prop, okay? So that's just a reminder of algebra proofs. Today, what we're gonna do is go to this page right here. And I just wanna take a look at this to make sure. There is, this right here is on your cheat sheet, right here, okay? So, one of the things that we're gonna talk about today is midpoint theorem. I think you guys all know what a midpoint is, but if something is a midpoint, if M is the midpoint, that tells us that this side and that side are congruent. So whenever you guys see that you have a midpoint, what that means is you're going to use midpoint theorem. If they give you a midpoint in a proof, you're always going to use it, okay? So don't forget about that. So what happens is they would tell you M is the midpoint of AB, and then you would say that that means AM is congruent to MB, okay? And that would be by midpoint theorem. And how I abbreviate that is I do MIDPT, and then theorem, I always do THM, okay? So now, if I look down at this next proof, this is like a combination geometry proof and algebra proof. Starts out as geometry, and then it changes into an algebra proof. So for this one right here, we are given step 1 that P is the midpoint of JK. And I always use MIDPT for midpoint. Okay, and that is given. Now, whenever you are given that you have a midpoint, that tells us that we're going to be using midpoint theorem, okay, all the time. So what that would mean then is that JP, segment JP, would be congruent to segment PK. So let's write that down. We would say segment JP, so it would have a bar above it, is congruent to PK with a bar above it, okay? And that is by this midpoint theorem up here that we just learned. So I would be MIDPT and then THM. Okay. Now, what we're going to do, I'm going to go to this next page here. And I don't remember if this was on, it actually is. Okay, so then right below the midpoint theorem on your cheat sheet is the step that we have to do next. So this is a little bit confusing, but when you have to substitute in measures into a segment, you can't do it with the segment bars on or the squiggly. So what you have to do a lot of times in proofs is take the bars and the squiggly off, and then sometimes at the end of the proof you have to put them back on. Whether we take the bars and squiggly off or put them back on, it is called definition of congruent segments, okay? So if we go back here to our proof, all right, what I'm going to do next is I'm just going to take the bars and the squiggly off. And again, that is definition of, whoops, not sure what happened there. Definition of congruent segments. Okay. That is the geometry part of this proof. Now we have, so again, you can't substitute into a segment. You have to take the bars off because now this means the measure of JP equals the measure of PK. And if you look down here at this diagram, JP equals X, so I can substitute X in for JP, okay? We also know that PK is 5x minus 8, so I can substitute that in here too, okay? That is substitution property. And remember you guys, when you do substitution, you have to go SUBST. You can't just go SUB because that would be just like subtraction too. You have to distinguish between subtraction and substitution. Now, we're back to an algebra proof. And when I do these, I always try to get my x's onto the left-hand side. So what I would do is try to bring that 5x over to the left by subtracting it, okay? So I'm going to subtract 5x from both sides, and I would get negative 4x equals negative 8, and that would be SUBTR prop. Okay. Then our last step is going to be just solving for x. So we would divide by a negative 4, and x would equal 2, and that we divided, so it's division prop. Now again, remember, you can always kind of cheat and look back up here and make sure that 2 is what you were supposed to get. If it's not, then you did something wrong in your algebra, okay? All right, another thing I just wanted to go over on this page. If you put the bars and the squiggly back on, that's also called division of congruent segments. And then this, we already did one like this, but if you ever have a midpoint, that is going to mean that, so like the drawing for this one would look like this. It says M is the midpoint of LN. And if they told us M is the midpoint, you would then say that these 2 pieces are congruent by the midpoint theorem. Okay? All right, so let's try one more like this. So here, when you have a geometry proof, you can be given 2 things, 3 things, even more than that. Usually the most you'd be given is 3 or 4. When you're given more than 1, you're gonna want to either write them both as step 1. That's what I generally do. I put all my givens under step 1 and I write given. But some people will do 2 separate steps that are given. Either way works fine. So if I was doing this, I would write both of them under step 1. And then I would write that that is given. Okay. Now, I was saying to you guys earlier, if you are given that you have a midpoint, that means you have to use midpoint theorem, okay? So if L is the midpoint of JK, you can say then that segment JL is congruent to segment LK. So let's go down here and do that. So I'm gonna say segment JL is congruent to segment LK. Okay, and that is the midpoint theorem that we just learned. Now, in a geometry proof, one of the ways that you can kind of look back at and try to help you when you get stuck is look back at what you're trying to prove. And we want that LK is congruent to MK eventually, okay? We want that this one and this one are congruent eventually, okay? If you guys look, do you see how these 2 are the same? Did we learn something last week that said if these 2 are the same, we could get rid of them? Do you guys remember that? Do you remember what it was called? Syllogism was when it was with sentences, yes. Do you guys remember like when we learned transitive property? Do you remember that? Maybe I should go back and review those because I know it's been a second. But do you guys remember how reflexive property was if something equals itself? Symmetric is if you take something and flip it around, okay? And then transitive is if the ending of this and the beginning of that are the same, you cross those out and then the outside 2 are equal. And transitive is something we use quite a bit in these proofs. So because JL is here and here, what you can do then is you can get rid of them. So kind of think of crossing those out. and you can say that MK is congruent to LK. So it's like you've crossed the JLs out, and that is transitive property. Okay, now, if you guys look up at what we want to prove, isn't this just in the opposite order as this one? Do you remember what I said we call it when we just switch the two sides? That one is symmetric, okay? So the last step we'd have to do here is say LK is congruent to MK, and that is symmetric property. Okay? All right. So sometimes you just have to flip the left and right, and that is symmetric. Now let's go to our last page here, okay? And write down our given. And again, with the given, you can write both of them under the same step. So I'm gonna say C is the midpoint of AB, and B is the midpoint of CD. And I'm doing both of those under step 1 and just writing it as given. Okay? Now, when they tell you you have two separate midpoints, that means you're going to do midpoint theorem twice. Okay? So the first thing they say is C is the midpoint of AB. So that tells us those two pieces are equal. So I would say AC is congruent to CB, and that is the midpoint theorem. So because C is the midpoint, I can say those two pieces are equal. Okay? I also know that B is the midpoint of CD. So if I go back up there, okay, B is the midpoint of CD. That tells me that this piece is congruent to that piece. So I could say CB is congruent to BD, and I'd have the segment bars on there. So CB is congruent to BD. Now, that is also midpoint theorem. So if you wanted to, you could keep it under step 2. Or if you wanted to, you could make a step 3 and then put midpoint theorem again. Either way works. Okay. Now, let's look. We eventually want that this and this are equal or congruent. Anyone notice something there that we could do? Transitive again, right? Where these two CBs cross out. So I could say then that AC, segment AC, is congruent to segment BD, and that is by transitive property. Okay, so these are just some like introduction ones that you're gonna have that are geometry. I can tell you on the worksheet today, I think you might have one that's a geometry proof. But on your quiz that's coming up on Wednesday, they're all algebra. So those ones should be easier for you. And then if I haven't told you this, Thursday and Friday are probably gonna be 2 of the hardest days of the year. So if you can try not to be gone those 2 days, that would be good. And then next week, Tuesday is also going to be like that. Maybe it's Monday. and Wednesday next week. Both of those days are hard too. All right, so I made up a worksheet for you guys. It has some from what I taught today, but then it has a review from the whole chapter. So you can work on this. And here's the deal. I'm kind of torn with you guys because some of you work really well in groups and some of you don't. So I'm gonna let you work with somebody, but if I notice that a group is not working, then I'm gonna ask you to split up, okay? So I will let you work with 1 or 2 people, and then you can, as long as you're working, you're fine. If I ask you to split up, then that will be the case for a while. And then I have a key for this worksheet in Schoology, as well as I have a key right here, you guys, okay? So if you'd rather use the one up here, otherwise if you open up Schoology, there should be a link there for you also.